Hello everyone. In this video, we want to model a DC machine and also control that by using a PID to operate a DC machine in the, the reference speed that we want to operate. So for that one, first we should start by adding a DC machine. So we can search here. So this machine, so it can be motor, generator, and if you double click on that, we can see we have the mechanical import torque. We have some parameters here, so we just stick to the default values. So we need some constant value for the inputs of the torque. So we put 1 as a 1 per unit. And the M here is the output. So the output of the measurement is M. F is field voltages, and A is the voltages in the output of the motor. So for field voltage, typically we use, if you go to Simulink, electrical special power system, source, we use normally one DC source. So put the DC source here for the field. And for A, we should add for the armature, we should add the controller. So the PID will go here. And for that one, first we need a voltage controller here. So the voltage controller is the inputs like here. So we can add also the AC voltage, but this one is controller. So here we have the input of this voltage controller. Easily, we should apply the PID here to control this voltage. Then we'll control the armature voltage, and then we will have the required value. So we need one PID, one controlling here. And for observing the output, we need one bus selector. If you put the bus selector here, then we can connect the input to M, and output you can see now we have 2. So if you connect the bus selector to any blocks in MATLAB, then automatically it will see what inputs we can have from this block. So we need a speed. Just click on add and remove these 2 and cancel. So this one is now the speed. So we need one reference and one summation here also. So now we have this reference. We, for example, putting in 1700, and we make a difference here. And this is the output of the DC machine. So it makes a differences here, and here is the differences. For example, if this is 1700, the speed of this one, then it will be 0, then we'll have nice control. If this is 1800, for example, then the difference will be minus 100, then the PID will act and will put it back. So without changing any parameters, because we working the default value, we need also one specialized power GUI here. Just change it to discrete. Okay. So if we run the simulation, if we open the scope, you can see here is it started from 0 and went for 1700 without changing anything. So if we, for example, change it to 1000, if we run it again, we can see it went to 1000, so easily. So, but it takes, for example, 3 seconds for reaching to the required speed and going straight. So we can play with the PID to reduce that, for example, to 1 second or less. So for this, if you click on the PID Here you will have the PID, the P is 1, I is 1, and D is 0. If we click on tune, automatically we can tune and change the parameters for this PID very easily. So here we have the tuning page. Here we have the response time. We can make it faster, for example, and we can make it, for example, robust. It depends on what system you need. Just this is as an example. And update block. You can see here the block is updated. If you click OK and run simulation again, so you can see here it was 3 seconds for reaching to the 1000. Now is around 1 second.